So example 2, an F-16 starts at rest and accelerates at 30 meters per second squared. Well, at least they give us the acceleration this time. How fast was the jet going? How fast was the jet going after 4 seconds? So on paper, at rest means zero velocity, but it is a velocity. And we're starting at rest, so this is going to be V0. Okay. Accelerates at 30 meters per second squared. It tells us that's an acceleration. It asks for how fast the jet was going after 4 seconds, so that's got to be a later velocity. That's our later velocity. And then our question, and then we have 4 seconds, which is a time. So just be careful, this one's our question word. Okay, first step, read twice, we've done that, draw twice. So now I'm gonna draw a picture so I have an airplane. Look at my fancy airplane. This is how pilots draw airplanes. You make an X and give it a little tail, and now you got an airplane. It starts at rest. Okay, so V0 is equal to 0 meters per second. And then it's going to accelerate at 30 meters per second squared, and it's going to accelerate for 4 seconds. So it's going to take time of 4 seconds to accelerate. And at the end of that time, what is the second velocity? So we're starting at 0, not moving, and then we're going to speed up. Okay, we're going to put on the afterburner and we're going to get ready for takeoff. We're speeding up really, really fast. Okay, so now I'm going to do my givens. So I've read twice, drawn twice, and now I'm going to do my givens. R2D2 guess. So let's start with V0 equals 0. Acceleration equal 30 meters per second squared. Time equal 4 seconds. And my question is V1 equals question mark. And that's my unknown. Now I'm going to go to my equation sheet. So let's take a look. This time I'm looking for V1. Now notice V1 happens to be the very next equation. It actually is a simpler equation, I think. V1 equals acceleration times time plus V0. V1 equals acceleration times time plus V0. Okay? Just FYI, this is exactly the same equation as y equals mx plus b. If you were to graph this, V0 would be the y-intercept, A would be the slope of the velocity graph, and T would be the x-axis. So let's plug in our values. So V1, do I know it? No, it is a question, so I write the variable. Acceleration is 30, in parentheses 30 meters per second squared, times time of 4 seconds, plus V0 of 0 meters per second. Continue to show your work. 30 times 4 is 120 seconds, and one of those seconds cancel. So just like x squared times x, one of those x's would cancel, and you would be left with 1 over x. We are left with one of those seconds there, so 120 meters per second plus 0 is 0 meters per second, and so we have 120 meters per second is our V1, is our ending velocity. Be careful, that is our ending velocity. Okay, and we are done. So notice, this one we didn't need the picture as much, but it did help us to have this table kind of listed out in order. Okay, the one part that you have to be careful with all of these, and I'm going to stress it again, we've already talked about a little bit, but is hidden values where there's no number, but at rest means it's not moving, so that must be a V0 of 0 meters per second. Otherwise, straightforward. Make sure you're showing all your steps. Don't skip steps on me. You will only hurt yourself if you do that. Moving on down the page here. Solving for distance. Example 3, a car known as a drag racer starts at rest and will accelerate at 33.3 meters per second squared for 3 seconds. How far down the racetrack will the car travel? So this time we have starts at rest, which is V0, and will accelerate at 33.3 meters per second squared. That's really fast, by the way. So that's acceleration for 3 seconds. That's a time. And then how far down the racetrack? How far is a distance? Okay, so now I'm going to draw this picture. So my drag racer, guess what? Looks just like a regular car, except it's got a big back wheel and a small front wheel. And it's going to start at rest, and it's going to, so let's label that V0 equals 0 meters per second. And we're going to get the green light, ready, set, go. And it's going to accelerate, draw that acceleration arrow, 33 meters per second squared. And it's going to accelerate for a time equal to 3 seconds. And that's an S, not a 5. 3 seconds. And at the end of its race, how far down the track did it go? So we're actually looking for this total distance that it traveled. How far down the track did it go? Okay. Notice we're also missing another piece of information, but we don't need it to solve this problem. Okay, so we've read it, we've labeled it, we've drawn it, we've labeled it. I think this tells a complete story. We don't know what the second velocity will be, but we really don't care about that. Okay, so I've got a good story, and let's start our table. Given, put my box around it, I forget that. Given is V0 equals 0, acceleration equals 33.3 meters per second squared, and let's see, time equals 3 seconds, and D equals question mark, and I've made a mistake. I left off my units. That will cost you points, so don't leave off your units. This is my unknown. I don't know what this one is. And now I'm going to write my equation. My equation is going to be equation sheet. This one right here. How do I know it's that one? Because I'm looking for D equals. So we have two D equals. We have D equals here, and we have D equals here. Well, both of them I have velocity and I have time. But look at your table here. I also have acceleration, so I have to use this one. I have to use this one because it has acceleration. Okay? So we have to use this one because it has all the pieces that we need. The key word is acceleration is the other hand. Acceleration, I got to use that one. So distance equals 1/2 t squared plus V naught times time. And this is how it's written on our equation sheet, but this is confusing for most people. So we're going to put that in parentheses, put the half in parentheses, so that when we do our next step, the substitution, we're going to substitute everything into parentheses and we will understand what we're multiplying by. Okay, so distance, do I know it? No, I do not. So the distance is D. The half stays in parentheses, and now I'm going to put my acceleration in parentheses, 33.3 meters per second squared times my time squared, so the time squared, which is 3 seconds, plus V naught, which is 0 meters per second, 0 meters per second, times a time of 3 seconds. So there's two ways to go from here. Personally, I would probably do one step at a time and write it down, or we could also go straight into our calculator, and we are going to be using Desmos. You can just type in desmos.com. You can go to Math Tools and Scientific Calculator. Click on the Scientific Calculator right there. And because now we can use parentheses, and I'm just using the keyboard to type this. So I'm going to put 1/2, close parentheses. So you may have to use the arrow keys to move over to where it needs to be. So 1/2, next parentheses is 33.3, close parentheses. Next parentheses is 3, close parentheses. And now I hit the squared button, which is right here. And then plus parentheses 0 times 3. Now we should know that this is going to become 0, and it does. And look at what we get for our answer. So our final answer is D equals, here, let's switch over, back over to this. So our final answer is D equals 149.85 meters, because all our units will cancel out. So second squared cancel, and we are left with meters. So this winds up being our answer. So just kind of as a quick recap, we are going to, okay, make sure that we're drawing our picture and labeling. Different parts of the picture might help us figure out the story. We're going to write our givens. In this problem, the givens are probably one of the most important things you can do. Okay. For our equation, we're going to go look at our equation sheet, and we're going to look for the equation that has acceleration. And then when we do write our equation, we're going to put the 1/2. We're going to put it in parentheses so we don't get confused about how things are multiplying or dividing and all that. Also, make sure you put the time squared in parentheses. We are only squaring the time, only that one. These two are outside of the parentheses and are not squared. So only the thing that's in parentheses gets squared. Okay? And my autofocus is driving the camera crazy. Okay. And there you go. Please use a calculator. Please use parentheses. Okay? Parentheses is your friend. Order of operations is your friend. Whew. All right. So we have done one of each type of problem. At this point, I'm going to actually do one more problem where we don't know what type of problem it is, so you can see how I think through the problem. This could be any one of the 3 types we just saw, but I do want to stress this one will have a negative acceleration, so you probably want to watch this one.